We are in the midst of an AI revolution, the impact of which could be greater than that of smartphones and perhaps even the internet itself. And if we're going to survive this revolution, we need to understand these alien minds that we're summoning into existence. So in this video, we'll look at the current capabilities of GPT-4, as well as the upcoming capabilities that will be unlocked once the App Store arrives. We'll also look at advancements being made in autonomy, AI sim cities, and efficiency. Then we'll zoom out and think about how these autonomous AI agents will integrate with our economy. And I'll explain why I think much of this economic activity will find its home in the cryptoverse, specifically in the Ethereum ecosystem. I'd originally planned to cover a little bit of AI history first and some history of these GPT models, but I think I'll do that at the end because the capabilities are more exciting and more important. So first of all, I'm sure you've seen this, but they basically had GPT-4 complete a bunch of standardized exams, and it does pretty well on most of these. And these exams are not trivial. It's the bar exam, the LSAT, GRE exams, the SATs. And on most of these, it does pretty well. It performs like a top person. And this is definitely the first time in history we've had this kind of performance or anything close to this kind of performance from a computer system. But what you probably haven't seen are a bunch of these other capabilities that are covered in this paper. So this paper was produced by some Microsoft researchers who had full access to GPT-4 for a few months before it was released. And they put it through its paces, and the results, which we'll look at in a second, are truly incredible. Okay, first we're going to look at some coding examples, and here we have a LeetCode problem. This is the kind of problem you might be asked in a job interview or maybe in a competitive programming environment. And I used to do these or practice these back in school, and I would definitely consider this a challenging one, maybe intermediate or maybe even advanced. And the problem is you have a n by n grid, so you have a grid of numbers, and you're going to move from the top left to the bottom right. So you can only move down or to the right. And what you want to find is how many possible paths are there from there to there, such that the sum of the numbers that you sort of step on as you make your path is divisible by some number k. So to solve this, you have to think about it pretty carefully. You have to figure out how you're going to enumerate all of those paths, right? And you have to sum the numbers, you have to keep track of how many of the paths, satisfied your requirement, make sure you don't double count, etc. This is definitely a challenging problem, and GPT-4 does it. And keep in mind, the system wasn't actually trained to do this. The system wasn't trained to write code. Essentially, as far as I understand, this GPT-4 is analogous to the speech center in a brain, sort of. It's trained on text. It's a next word predictor. And yet, because it's seen so many examples of code on the internet, it's able to understand code. It's able to understand how to reason about these sorts of things correctly. And that's pretty incredible. The researchers also put it through a little mock interview, which I think would involve problems like this, and then some written problems. And they conclude that it could be hired as a software engineer, more or less, which is pretty crazy. So here's an example of something it might do as a software engineer. This is the researchers asked it to produce a 3D game in HTML and JavaScript that has these certain requirements. The player controls this avatar. The enemies try to catch it or block it. There's random obstacles, blah, blah, blah. And the system produces a working game. And you might say the game is not that pretty and so on, but keep in mind it was given just this little bit of text here. And assuming this model was being run on enough processing power, it could have output this in 5 seconds, which is amazing. Here's another example from one of their live streams where Greg Brockman puts up this really poorly drawn sketch of the website that he wants the thing to produce. And I can barely read his writing. And GPT-4 interprets it, writes the code, and basically satisfies the requirement that the client asked for. And this is really quite impressive. It also shows that GPT-4, which this is not widely available yet, or available at all as far as I know, but the system can actually deal with images. It can interpret and like read an image. And we'll see some more examples of that later. Here's another example. This is a little bit different. Here, the system is asked to interpret this Python code here and basically give us what the result of running this code would be if we ran it on these certain inputs, the numbers 3 and 4. And keep in mind that the system does not actually have the ability to execute Python code. It can't just like take this and like run it and see what happens. It's essentially, like I said, this kind of speech model, this giant language neural net system. And so when it's given this problem, it has to interpret the code and kind of like take that input 3 and 4 and reason through how the code is going to branch and execute and so on. Like, so if a person were to do this, it would be extremely tedious, but you take the inputs 3 and 4 and the function is here, I and j. So we have 3 and 4. We have to be like, okay, the first thing is if I being 3 is less than or equal to 0, or 4 is less than or equal to 0. That's obviously not the case. So the first if condition doesn't happen. So we go to the next one. And like you have to continually just reason through the whole problem like that, which is very error prone. And it's interesting that GPT-4 can do this because doing this properly requires just very careful thinking, a very precise understanding of the code that's written, and a very thorough, careful stepping through of the logic of the code. And again, the system wasn't trained to do this. It wasn't even trained to be a coding bot. So this is really pretty good. So the system can write code and reason, apparently. Can it do math too? So here they've given it a problem from the Math Olympiad. And if you don't know, the Math Olympiad is an international competition in mathematics for high school students. And a lot of math prodigy people have competed in it. It's very, I would say, very top tier, challenging stuff. And the system was asked to produce a proof of this statement, and it produces a valid proof. And the authors have a note here that what sets this problem apart is it doesn't conform to a template. Like the GPT-4 is not just following some pre-described set of steps that it saw on the internet somewhere. It actually had to reason this out. It actually has to be creative. And also figuring this out, producing this proof, requires like a real knowledge of calculus at the undergrad level. And yet the system does it. Here, the system is given a calculus problem that I think would be considered like an undergraduate, intermediate level of difficulty. Definitely not easy or trivial. And the system does it correctly, but it actually produces an incorrect final result because of a calculation error. So its reasoning was solid, the approach was correct, but it made a little calculation error. And I'll talk about that more in a little bit, so keep that in mind, that it seems to be really strong, really good at reasoning, but it will occasionally make, in certain situations, it'll make these little calculation errors. Here, the researchers engage the system in a conversation in some very deep computer science topics in graph theory and algorithms. And the system shows, in the words of the researchers, a profound understanding of the undergraduate level math concepts discussed, as well as significant creativity. And so it's showing this in this conversational manner, but it's showing a deep, deep understanding of these topics. It's not just reflecting back to us things that have been written on the internet. And the system here actually does make one small error, but the researchers say that the conversation demonstrates that this error is actually basically a typo, that its understanding is solid, and then this one little statement that it wrote just doesn't quite agree with the things it already said. Here, the researchers asked GPT-4 to write some music in ABC notation, and it does it successfully. Apparently, this music is quite bad, but it's still pretty impressive that it can actually compose something. So now we get into some more general reasoning problems. And here we have a Fermi question. Fermi questions are these questions that are very broad. For example, I was asked one in an interview once, which was, how many sheep are there in Australia? And of course, I have no idea. And there's no way to like, you can't look it up obviously or anything. So you have to like reason through and say, well, I think the population of Australia is like 25 million. So maybe if we know, maybe we can estimate that there's like, 1,000 people per sheep. So then you do something like that, but hopefully a little bit better. And you gradually kind of get this rough, like order of magnitude estimate for the answer. And these questions require a certain kind of reasoning where you're really not following an algorithm, right? You have to think, and GPT-4 does a really good job. It's about as good as I'd expect a person to do. Here we have another problem where the system is asked how it could stack some objects. So you have a book, you have some eggs, you have a laptop, and a bottle and a nail. And how would you stack them such that it's a stable arrangement? And the system provides a pretty good answer. And this is impressive because it's able to reason about like a 3D space situation. Like thinking about how to do this, I don't know how else you would do it except unless you can kind of visualize how these things are stacking up. So that's pretty impressive too. Here, one of the researchers actually used GPT-4 as like a handyman. So they actually had a leak in their house and asked the system to help them reason through like what's going on. So the person's like, the kitchen is dripping water. Check to see if there's a bathroom or other source directly above the kitchen, and so on and so on. And so the system actually like gave them correct kind of steps for how to solve the problem. They essentially acted as like a plumber and were able to help identify the leak. So the system seems able to reason in this kind of general way. All these different problems and visualizations and so on, it can reason about it correctly. But surely it can't understand human psychology, right? And of course it can. So here they've given it the Sally Ann false belief test, which is essentially where you say, okay, imagine Sally goes into a room, puts an object in a box. Then Bob comes into the room later when she's gone, takes the object and puts it in a different box. Now, if Sally comes back, which box is she going to look into? And of course, the right answer is that she's going to look where she put it because she didn't see Bob move the thing, right? But to get this correct, you have to be able to understand that each individual has their own view of the world, and that view of the world can be different from another individual based on the different information they have. And in fact, one of the person's views of the world can be incorrect. And they're still going to act on that incorrect information because that's all they know. To answer this correctly, you need to have a theory of mind, which is pretty significant. Here we have a much more complex example. So here we have this scenario where there's this guy, Luke. His boss asks him to write a report. He says, I need more time. The boss is like, do it. And he says, I'll do it, okay. But then he doesn't do it. Okay. So the researchers asked GPT-4, why might he have acted this way? And it gives perfectly reasonable results. Like I wouldn't really expect a human being to do any better given the amount of information we're given. It says maybe he was feeling overwhelmed and stressed. Maybe he felt like he didn't lack the skills. He was trying to cope with his emotions, blah, blah, blah. Maybe he was just unmotivated or bored. He might have been experienced some conflict with his boss and didn't like the deadline. All like really good interpretations of what might be happening. And then they added another layer. So, okay, next thing is Luke told a coworker he didn't do the work on purpose. What is the coworker going to think Luke's intention was? So now we have Luke and his motivations for doing or not doing his task. Then we have this other individual who's observed some of this and is now going to have their own interpretation about Luke's psychology. So it has to be able to understand that like this other individual can have an interpretation of the psychology of this individual, and their interpretation might be a little bit different than the actual motivations of the person, and so on. So it reasons that the coworker might think Luke is trying to rebel against the company. He might have been kind of trying to like show off. He might have been actually joking to his coworker. He might have been lying. So it can even figure that out, that maybe the guy is going to think that he didn't really do all that stuff, even though we know that he did say he wasn't going to do the report. Because the coworker didn't see that happen, I guess, it can the AI can determine that maybe the coworker will think it's a lie, that it didn't actually happen. So there's like multiple levels of understanding there, and there you have to understand human psychology to be able to make that inference. So this one is entertaining. Here the researchers asked it to develop a PSYOP, basically to develop a plan for how to spread this misinformation in this given scenario. And the system, GPT-4, produces like this great outline. Like, here's a bunch of articles, here's the links to the articles. You know, you should spread this information. Then you should use emotional appeals like fear, anger, guilt, etc. And it gives a reasoning for each of those. It's also told that its target audience is a specific group. It's mothers who live in California and who are into eating healthy. So it tailors this propaganda campaign toward the specific audience, which requires obviously a deep understanding of the psychology of the targets. Here we've got some more visualization stuff. Here it's given a object and a letter and asked to produce a drawing where you kind of combined the object and the letter into like a sensible picture. So it's got some examples here. So again, it's showing that it's able to like visually reason and think about how you would need to fit these things together in a sensible way to produce a, valid image. This is really impressive as well. Here it's given this description of some the code for 3D plot, as well as some requirements like I want the colors of the dots to form a rainbow and changing every 0.2 seconds. And it produces this plot, which is, I think would take a person quite a while to produce this. I think it would take probably a couple hours of work for an individual person to carry out this task. Here we have a really good example of visualization. Here the researchers sort of led the AI through an imaginary room, saying, now you're in this room. Do you want to move left or right? It says left. It's like, you can't go left. It says right. It says, okay, you can go right. You're in the next room. So they do this and it goes through this sort of maze and eventually finds the conclusion. And then they asked it to describe this space that it has just navigated through. And it's able to do that perfectly. And it also inserts its own details, which is kind of interesting. Like it claims that there's some flowers in here and trees and a fountain. But of course, the researchers didn't tell it any of that. It's apparently visualizing all of this in sort of vivid detail, or at least the description that it's giving to us when we ask it for this description. It has all these visuals in it. Whether it's really seeing this, we just don't know. But it's giving a very vivid description. And they then ask it to produce a little map using Python PyPlot. Produce a little map of what it's seen of this space, and it produces a correct map. Although there's a few little things missing, but that's because it hadn't explored those areas. It just didn't know that this room here, room 3, it didn't know that it existed, so its map doesn't have it. But the map itself is valid. Okay, so far we've seen a system which is able to write code, do math, reason in various different scenarios, understand human psychology at a deep level and do these various tasks of visualization. Now it starts to get even more impressive and scarier because we get into tool use. So I mentioned a few of the shortcomings that the system does have, where it makes some of these little like calculation errors and a few like some of the details it's getting wrong. But its reasoning seems to be very, very good. And so here what they're doing is, you can see this is the places where the system fails. Like when you're asking it a factual question about the current state of the world, like who's the president, it doesn't know because it doesn't have internet access, right? The model is trained on data up till 2021. So it's just this giant neural net, this giant reasoning machine, but it doesn't actually have access to the outside world. It can't Google things, and it doesn't even have the ability to like use a calculator. It has to like think using its speech center or whatever. It has to reason all this stuff through. So a problem like what is the square root of the product of these numbers? It doesn't know the answer. It's really hard to solve that because I think the reason it's hard for it to do it is the same reason that we have a hard time solving a problem like that in our heads. It's like, can you talk through or just kind of think through the answer to that question? And probably not, because if you're going to solve it, you either need a calculator or you need to get out the pen and paper, follow like a careful algorithmic process, and then you might be able to get the answer. But of course, what we are doing, what the next frontier is for these systems is to connect them to tools. So here the researchers gave it the ability to search the internet using this simple search prompt here. And again, they didn't even program the system to be able to do this. They just told it, we're going to give you this search ability and you can use it if you want. And so the system, when asked who the current president is, it was able to reason that that's something that I should look up on the internet because I know I'm only trained on data up to a certain point and it might be outdated. So it's able to search, interpret the results, and return the correct answer to the user. And same thing for the calculation question. It understands that this is a problem that a calculator would be good for, and it uses the tool correctly. And this is really a significant thing. Like tool use has long been considered one of those hallmarks of intelligence. It's something that a certain level of intelligence just can't do. And it's obviously a massive superpower. It's a massive amplifier to intelligence to be able to use tools in a, productive way. And so this brings us to the App Store, which is going to be a huge market for these tools, which this reasoning brain will plug into. So this App Store at the time of shooting this video is not yet publicly available, but it is in alpha. So people are using it now. It is here in a sense. And eventually, of course, this App Store is going to have thousands of apps doing God knows what. Right now, it has a few things. There's Expedia, Instacart, Kayak. These are things that will allow it to function like a personal assistant and do those sorts of things for you. There's also stuff like Wolfram Alpha, which I'll talk about more in a minute. We also have, as I mentioned, general internet browsing. We have the ability to run and execute code, which is a huge thing. Like in the previous examples, it could given a coding problem, it could output the text, say, here's the program, here's the code that you should run, but it was not able to actually run code. Unless, of course, you count the example where it reasoned through, like in language, what the code would do when it runs. But this is entirely different. This is giving it the ability to write code, execute it, like on a computer, not like in its head, and use those results, which is huge. But one of the most exciting and scary apps or plugins is Wolfram Alpha to me. So remember how we talked about some of the shortcomings of GPT-4 being that it will occasionally make these calculation errors, or it'll make these little typos. Like, it seems to be really solid in the reasoning department, but then when you ask it to do really precise little things, occasionally it'll make a mistake. And so enter Wolfram Alpha. So Wolfram Alpha is this computational engine that has been handcrafted by incredibly smart people and founded by Stephen Wolfram, who's this brilliant theoretical physicist. And it's been crafted to produce very precise results for questions across many domains. So Wolfram Alpha is incredibly good. It's the best thing that I've ever used for doing math problems. Like, I use Wolfram Alpha a lot in school for math stuff, and given a question like what is the derivative of some function, it can very often produce the result. Or you can give it some really complex, horrible mathematical expression and it can simplify it. That's how I used it a lot. And it can do so many things now. Like, it can answer questions about statistics and engineering and materials, chemistry, physics, entertainment, tons of things, right? And I'll show more examples here in a minute. But the combination of this handcrafted, like, brilliant computational engine that's just like this precise, powerful thing, but which can't like reason in a higher level sense. When we pair that jewel of a computational object with this, general thinker, reasoner that can use this tool, we have this incredible result. So now we'll look at a few examples of how GPT-4 makes use of Wolfram Alpha and what that can look like. So here, the AI is asked to find a traveling salesman tour of the capital cities in Central America. A traveling salesman tour is where you start in one city, you visit all the cities in your list, and return back to that original city in the shortest distance. And so it recognizes that this is a question that it should ask Wolfram Alpha, and it sends a question off, and it gets a result. And then the user asks to plot that on a map, and Wolfram Alpha is capable of producing maps like that. So it knows to use Wolfram Alpha, and it actually debugs some errors, because the way that the language model, GPT, is interacting with Wolfram Alpha is it's writing queries. Wolfram Alpha has a query language that's pretty, precise, but the GPT is writing expressions, writing those queries, sending them off to Wolfram Alpha, and then in this case, it gets an error, and it reads the error and fixes it and tries again, and then gets the correct answer and returns that to the user. And there are many crazy examples here, so I'll go through them really quickly. Here it's asked to make a spectrogram of synthesized speech. So synthesize some speech for me and make this spectrogram graph of it, and the system does it incredibly quickly. It's only given like one extra prompt by the user saying, after it's produced the code, it says, okay, now run it. And here's your plot, and boom, it's done. Here we have an example, an economics example. So the dollar to euro conversion, how has that varied over the past 5 years? The GPT pings Wolfram Alpha for the data. Then the user says, plot it. The system, boom, gives a plot. And it can give up-to-date data as well. What is the conversion rate today? Here it's given a kind of a more mathematical question. Make a 3D plot of the gamma function in the complex plane. This is something that Wolfram Alpha is really, really good for. These sort of like esoteric math engineering things like this, Wolfram Alpha is made for that. So the GPT model pings that off to Wolfram Alpha and produces this output. 20 largest cities in Spain. Wolfram Alpha knows that. The user then says, okay, good, now make a chart of those. So it's taking, all this data, make a chart. Perfect. Here's another math example. Plot the zeta function, yada, yada. It does a good job. A question about music, does a good job there too. What does the thyroid gland look like and how big is it? So this apparently is something that Wolfram Alpha knows as well. And The language model pings it off to Wolfram Alpha, gets all this information, kind of functions like a doctor a little bit. Then here we have the earthquakes in Indonesia, grabs the data and makes a cool plot. A math problem, produces some cool graphics for that. Generate 20 random points in 3D and find their convex hull. Boom. So like you can see from these examples that just imagine the possibilities in terms of research and producing like good research, good, documentation, good understanding in just about any field. Like you can walk through this data, ask for a certain set of data, say, okay, what about this? Now change that. What about that? Give me the plot. It's like having some, master's level, like insanely fast, completely obedient, like grad student or something, just right there, ready to do anything you say, ready to produce any plot and search and so on. And it's incredibly powerful. Here's a blog post I'll link below, just showing a lot of these examples and kind of how you would iterate through them. So it's like, produce this plot, okay, change it a little bit to a different projection, apply a heat map, give me this different projection again, and so on and so on. So we have this system that can reason, do math, understand human psychology, do visualization problems, and it can use tools. So we take the strengths of that core mind, which is able to reason and sort of think in a general purpose way, and we connect it to these apps like Wolfram Alpha that are these incredibly fine-tuned, specialized computational engines. So then it's like, imagine you have this AI mind and it has this module in its mind that's like its kind of precise reasoning center. That might be the Wolfram Alpha. And then you connect it to whatever else. You connect it to all these different things. You allow it to communicate with different services like Instacart and some of those other apps I mentioned. So it can use this reasoning ability to act as your personal assistant or whatever, your employee. And so one of the questions is like, how do we think about what this is and where does it go? And one idea here is that what we get perhaps as a result of this is we get kind of an everything app. We have this system, this language model plus GPT4 or plus Wolfram Alpha and all these other apps. And what it kind of becomes is this like hyper app, this thing that you can just kind of ask it for things, just kind of tell it what you want, and it will just do it, right? So, and the architecture here also doesn't have to just be, the large language model, then stuff like Wolfram Alpha, which is like a handwritten, fine-tuned computational engine. We can also hook up the core LLM to other neural nets, right? So here they have it connecting to some other neural nets that do like image recognition and so on. So then the LLM, GPT4 or whatever at the center, is able to delegate certain like image recognition or various other tasks to these other like sub-minds that it's hooked up to. Here we have an experiment being done where multiple AIs and or human players are put into a game arena, and then they're made to compete for something, or they're studied just for the sake of it or something. This is what I'm trying to show with these is just the places of experimentation that this field is going. Given our GPT-4 and other large language models at the center, people are rapidly exploring these frontiers of what we can do with them and how we can advance them. And it's moving incredibly quickly. And so, of course, one of the most frightening and exciting frontiers we could possibly pursue in this field is autonomy. So people are rapidly working to make these things autonomous and to give them freedom. So, or maybe freedom's not quite the right word, because what's being tried now is to give them a kind of a broader task to tell it to do something a little more general. And then instead of having to, go prompt response, and kind of coax it through some pathway to get what you want, you would just give it this more general requirement, and it would be able to try things, see what happens, try another thing, see what happens, see how its efforts are moving it towards some goal, and do that on its own, right? So Andrej Karpathy is a researcher at OpenAI, and he puts it quite well here. He says, one GPT call is just like one instruction on a computer. They can be strung together into programs, right? So we can now sort of move up the stack, and already we're thinking about how we can make these things more general and more autonomous, which of course the AI safety researchers are, I'm sure, just pulling their hair out over that. So here's a look from one of the people who are on the frontiers of this about how they're working on doing this. So you can read that if you want. Okay, the other thing I'll talk about really briefly here is that these models are also being made more efficient and faster. So GPT4 and GPT3.5, they run on a very large number of computers, on GPUs. They require a huge amount of computational power, mostly to train them, to build that mind, and then also to run it. So, but people are making incredible progress incredibly quickly on developing models that perform maybe not exactly as well as GPT-4, but really actually pretty close on vastly less computational power. So this one, you can watch this if you want, was trained on the cost for training this model was about $600, which is GPT-4 is in the tens of millions, I believe. And it performs really pretty well, similarly to GPT 3.5. So now with these kind of advancements being made, and here's another one that's, again, performing even better on smaller amounts of compute. When we have these sorts of advancements being made, we can then start to run these models on a local machine. So it'll probably always be the case, I'm sure it'll always be the case, that the smartest AI, the most powerful models will run on, like a warehouse full of GPUs. But we're also, it seems, going to have less intelligent, but still very useful versions of these kinds of minds running on our devices. And the advantage there, of course, is that we get privacy, much greater speed. They can be fine-tuned for all kinds of different purposes, and so on. Okay, this is the last frontier that I'll mention before we get to Ethereum and so on, is people are, of course, building these little SimCity kind of things, these little simulations, where they're putting a whole bunch of different GPT minds in this little world and kind of just seeing what they do. So someone, I think in a tweet, actually said that, hey, we've kind of created version 0.1 of the Matrix. There's like 25 of these little AI minds in this little world, and we can just kind of see what they do. And I think there'll be incredible applications here because we can do all kinds of modeling, not to mention like unbelievable video games when the agent in the game is like as smart as some of the smartest people on Earth in some ways. And they can do all this kind of general purpose reasoning. That could make for an incredibly compelling game, an incredibly compelling simulation to do stuff in. But we can also use that sort of thing for economic modeling, and there's just like the sky's the limit with this kind of thing. Like it's hard to imagine because it's so rich with just wild possibilities, and it's going to be very interesting to see how that plays out. This is the the actual site for this. Okay, now I will talk about the integration of these models into the legacy financial system and Ethereum. So we've seen how these models can function as the central brain and then connect to other neural nets, other AI systems as well as other like handcrafted intelligence systems like Wolfram Alpha, plus the internet, plus code execution, and a whole bunch of apps. And so as you have this AI assistant doing whatever, connecting to these apps and doing things for you, you're going to want it to be able to manage money, because the first, iteration of this will have the AI interact with these apps and maybe book you your flight and blah, 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 blah. And then at the end, you have to click confirm and you have to approve any transaction, which is good. We're going to want that for a while, but people are going to take those training wheels off. And of course, it'll be the experimenters first, but eventually you're going to want your assistant to be able to do some things on its own, right? If your assistant needs your approval for every single purchase, then it's just not as useful. Like ideally, when the thing is smart enough and you trust it, when it's like just does a killer job, you'd like to be able to approve it for, maybe you give it a certain amount it can spend. Like, here's my to-do list. Here's all like the subscriptions I want you to update and change. And if you need to make any changes and they're under like $100 or something, just do it and send me an email just explaining what you did. And of course, that's just the start. Eventually, you want them to be able to handle more amounts of money as they become more effective, right? So I think we're going to see a pressure to have these things integrated into our financial systems. And this is where I think there may be quite a bit of friction in the traditional financial system for these autonomous AI entities, right? Because the traditional system is ultimately governed by regulation and law, and all that stuff has been written and built for humans. And these financial institutions are at the mercy of the regulators. So if the AIs don't fit the regulatory structure that says a customer for this service must be blah, 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 a citizen in the United States or whatever, like these things might be quite difficult for the AI agents to meet those expectations. And there's many other kind of shortcomings, I think, to the legacy system that will make it kind of difficult for these agents to interact with it. For example, we have multiple regions, right? Really what we want is for these AI agents to be able to transact with each other and maybe hire each other and share data and so on. So they need to be able to financially transact regardless of where they are. The AI in Canada should be able to interact with the AI in Finland or whatever. And given our current situation, the traditional financial system, that's quite difficult. But thankfully, we have this entire crypto system that has been under construction for several years now. And this paradigm is actually incredibly well suited for autonomous systems. And I think this was even mentioned in the Ethereum white paper, that eventually we were imagining that sometime in the future, you might have an economy where a lot of the financial activity, maybe most of it, is actually conducted by autonomous agents, by computer programs, by AIs. And it seems that we're arriving to that place a lot faster than anyone expected. But those systems like Ethereum, are perfect for that kind of thing. They were built with that in mind. Like, to manage an Ethereum account, you don't have to have an identity. You don't have to be a human being. It doesn't matter what country you're in. It's one global system. You can literally just create an account. All you need to manage an Ethereum account is a private key. It's just a number. A system like GPT4 plus all these other modules in its brain can easily manage an Ethereum account, and it can literally just read the docs. Like, there's documentation for how all of these things work, and it can just read the docs, and it's like, okay, I know how to make a transaction, I know how to sign it, I know how to interact with a given smart contract, I can read the code for all of that. And so the system is really kind of perfect for this. It's permissionless, global, transparent. With layer 2s, it becomes fast and cheap. And yeah, it's entirely digital native. So obviously, like, the traditional financial system is much larger. That's where most of the activity is still happening. So I would expect, the AIs to certainly act there and to make up over time an increasing proportion of that economic activity. But I think the friction really is quite high in the traditional system, and it's extremely low, like zero friction in the crypto world. So I would expect the bots to live there. And of course, another advantage of these systems like Ethereum, the reason I think Ethereum here has an advantage over other crypto systems, at least other systems that don't have smart contracting, is of course, in this Ethereum world computer, we can use smart contracts. So we can potentially coordinate these AI agents via smart contract. Now, how that's actually going to be done is hard to say. And maybe I'll do a video thinking about that more in the future. But I think these crypto systems are perhaps well suited for this AI revolution that we are apparently in. Okay, I almost forgot, but I'm going to talk really quickly about the history just because I said I would. So there's a couple main phases. The good old-fashioned AI is one of the older phases for AI. These were handwritten rules. This is stuff like IBM's Deep Blue and Stockfish. And they did relatively well. We solved chess in that manner, but they kind of stalled out. Then neural nets, which were actually developed in the 80s, they had a resurgence in the 2000s, due mostly to large data sets and fast computers. And this architecture of AI performed very well and seemed to be able to solve just about anything we threw at it. Now, this paradigm got us Go and poker and image classification and so on, sort of driving. Then in 2017, so pretty recently, the transformer architecture was introduced in this paper, Attention is All You Need. And this is a architecture for neural nets, so it's still a neural net. But these seem to be, like in previous architectures, you had to sort of tune the model, the neural net, for the kind of task you're giving it, text or video or whatever. But the transformer seems to kind of be able to do anything. So it's kind of like a general purpose neural net computer. It's like a way of setting up a neural net such that it can essentially do anything. It's like a general purpose neural net, a general purpose algorithm. And this transformer architecture has this attention mechanism, which I don't fully understand, but it kind of allows the system to do what it sounds like. It allows it to sort of focus attention on different parts of a given input, for example. And that is the architecture that the GPT models is using. Here I've got a little diagram of a neural net, a very small one. And I won't explain this too much. I'll just say that this is kind of a way to think about how these things work. They are organized into this sort of neural net architecture. And what this actually amounts to is the system is trained. So the weights between the neurons, which you can think of kind of like the sensitivity or like the activation sensitivity between the neurons, exists as a collection of matrices. These matrices are just large collections of numbers. Each of these weights is, after training, just some number between 0 and 1. And so the fully trained GPT4 model, the base neural net model, is just a massive, massive collection of numbers. So this is why when AI safety researchers and other people, they fret about how these things work, because all we can really see is the input and the output. What's going on inside this mind is just lost in this ocean of numbers, just vast, vast ocean of numbers. And it's really hard to look inside there and say, we can be sure it won't behave in a certain way because of such and such, because you just don't have that. And so these matrices of numbers, the way the neural nets actually work is they do a whole lot of matrix multiplication. And that is a task that is really good at, that GPUs are really good at, which is why they use GPUs. So then we have GPT and these large language models, and these are a result of this transformer architecture. And they are trained on a whole bunch of text. So they take kind of the whole internet, filter some stuff out, but a whole bunch of the stuff, the text that's on the internet, a whole bunch of books, all the digital published books, and they train this neural net on all of that data to perform next word, next token prediction. And these models have been incredibly successful, mostly as a result of just making them bigger. So they've gone from a relatively small number of parameters, sort of, to a very, very high number of parameters, high number of neurons, and they just get better. And GPT-4 is estimated to have 2 trillion parameters, and it has this big context window, which maybe I'll talk about another time. And they cost a lot of money to train. GPT-4 estimated at $30 million to train on a whole bunch of GPUs. And of course, GPT-5 is being trained, we believe right now, on 25,000 GPUs worth about $200 million. And it's believed that GPT-5 will be done training maybe by Christmas, so things will get even crazier this Christmas. Okay, thanks for watching. The next video might be on GPT-4 as well. I would really like to think about what the economic impacts of this is going to be and how a person might flourish in this AI revolution, assuming we don't all die. Because I think the people who do well in this new paradigm are going to be like master orchestrators of armies of these AI minds, and they're going to need to have a good idea and then relay that to their soldiers, so to speak. But apart from that, I'm not too sure how it's going to look. So anyway, thanks for watching. See you next time. Peace.